Let's start with a Class A address. The Class A address defines numbers in the first octet, which range from 1 to 127. An example is network number 24. Now with the Class A address, only the first 8 bits of the overall 32 bits in the address are used to define the network ID by default. Of course, we can change this with a subnetting procedure, but by default, only 8 bits of that address are used to define the network. If you have any IP address which has a number that falls in the range of 1 to 127, you are dealing with a Class A address. Therefore, you get a grand total of 127 networks, which could have been originally assigned to internet companies. But each of those 127 networks yields a grand total of 16.7 million hosts on a single network ID, giving you an incredible amount of possibilities for the number of subnetworks or hosts that you can add to a Class A network. In case of a Class B address, you have a range of 128 to 191. In this case, the Class B address uses the first 16 bits to define the network portion of the ID, which yields quite a few more networks that could have been assigned originally by the internet community. 16,384 to be exact. Notice that we get 65,534 hosts on each one of these networks with a Class B. Now, you know that if the first octet falls in the range of 128 to 191, you're dealing with a Class B address. You can actually draw a line of separation right after the first 16 bits, because this much of the address will never change when dealing with an IP subnetted environment. Class C addresses were designed for the smaller companies. You can see that they have a range of 192 to 223, but they use the first 24 bits to define the network portion of the ID. This means that approximately 2 million networks could have been assigned to smaller companies that use the internet, but each of those only yielded a grand total of 254 hosts, because I have only one octet that I own for my modification. These classes of addresses are important because they define the default points of separation. In other words, how much of the address is going to remain static no matter what I'm doing with it. For instance, with a Class A, I always know that the first 8 bits will remain static. With a Class B, the first 16 bits will remain static. And with a Class C, the first 24 bits will remain static, even if I choose to use what is remaining for subnetting. I always keep whatever that classful boundary is. It's going to be the same for that situation.